Welcome back to another episode of SEEK Bytes, the podcast for engineers by engineers. I think I got it right that time, maybe for the first time in the entirety of the 3 seasons that we've been recording. My name is Seamus, and I am joined by Elliot.
Hello.
And
also,
Will.
He's lying. His name is not Seamus. It is a lie. He's been lying to us for years.
Glenn. Oh, I thought you were going to say it, and I was like, Glenn, you better edit this out. And we're also joined by Will I Am.
Hello.
Today, we're going to be talking about Spec Kit. That's GitHub Spec Kit. More generally, about spec-driven development with AI. There are other options, but the one that I've spent the most time with is Spec Kit. We've done episodes about skills and tools, and we've had this whole season of AI, but this seems to be the big thing that a lot of people are driving. It's definitely being driven pretty hard at SEEK. And so in this episode, I'm going to share a little bit of my wisdom and my experience using this tool.
So, spec-driven development. So we'd say this is SDD.
What is it? What is STD?
SDD, spec-driven development. So probably the acronym for something-driven development people are familiar with would be test-driven development, right? TDD.
DDD, BDD, TDD are kind of the
behavior-driven development, test-driven development, spec-driven development. I've never done BDD. I've done TDD. I did TDD a lot when I first started at SEEK, when I came in as a grad some 8 years ago. Slowly sort of dropped off doing that as a constant practice, but continued to teach it to people. So whenever grads would join our teams or junior devs would join our teams, I would teach them TDD because I can see the value in the practice. But I think, just as a tangent, I think something that people struggle with TDD is in a large growing code base where you don't quite understand exactly what it is you need to build. TDD can add a lot of friction, which I think is a good point to circle back on with spec-driven development. Is some of my findings is that it does add a lot of friction, but the trade-off, I guess, in this case is that you can move a lot faster with AI doing this stuff. The quality that it outputs is significantly higher in my experience.
What I really like about TDD is that because you have to really think about what you're doing ahead of time, you have to know the test that you want to write. If you don't know what test you need to write, there's 2 fundamental problems about the system you're working in. Either 1, you don't understand the problem you're trying to solve, or 2, the code is structured in a way that is not testable.
Yeah, and I think that the 2 things you just said kind of really hammer home why a lot of people avoid TDD, because they haven't spent enough time in the code base to have a good, solid understanding of the structure of the code, the components, and how they hang together. But more importantly, and I think this is the bigger one, is that a lot of code bases are not written in a really test-first way, which is where TDD comes in handy. And I think something that I want to add for people before we start talking about spec-driven development and GitHub Spec Kit is that these are not mutually exclusive things. I use TDD with Spec Kit at the same time. And the reason for that is because with TDD, when you build your tests first, if you're following TDD's red-green repeat process, you're producing, and your AI is producing, the minimal amount of code to pass the test, which is something a lot of people get. I definitely got frustrated with when I started using AI. Was AI will go off on a tangent and fix things that it wasn't meant to be fixing. It will create obscure abstractions that make the code harder to understand. And getting it to do TDD and spec-driven development actually helps it stay on rails and kind of guide it to only make the correct change at the right time in the right place. With some exceptions, obviously, I think like any AI tool these days, you can definitely use it the wrong way and produce bad results. So, let's go back to what Will said originally.
What is it?
Yeah, what is spec? We still haven't said what spec-driven development. So spec-driven development. Spec-driven development. So here's the thing. I'm not super familiar with spec-driven development outside of my experience using it with Spec Kit. But after using Spec Kit, my interpretation of it would be essentially if you and a product manager sat down together and you worked through the user stories. So you came up with a bunch of functional requirements first. So before you even start writing code, before you even start writing a Jira ticket, you would essentially come up with what the functional requirements are. You'd come up with the user stories from those functional requirements, and then you would probably, hopefully do TDD or whatever to implement the user requirements and the functional requirements. And that's essentially probably what we've already been doing, right? Like most of us are familiar with, we write a Jira ticket. Hopefully it's got a user story. It's got acceptance criteria. That is essentially spec-driven development, at least as far as the parallels that I can draw between what Spec Kit produces and what we do at SEEK and what probably most companies do. looks really similar. It's just that the quality and the content and the detail that is created as part of Spec Kit is much more thorough than what we tend to do day to day.
The Jira ticket is your spec? Is that kind of...
It's a part of the spec. So
Right, okay.
so let's say that you're doing, like, we're doing projects at SEEK, for example, that run for 3 months, 6 months or whatever. They go across multiple teams. If you were to upfront generate a portion of all the features that all those teams are going to build, that's your spec, essentially. So you could do like phase 1, phase 2, phase 3, and phase 1 includes all of user stories XYZ. It's got functional requirements ABC. That's your first spec for phase 1. It's not like just the one Jira ticket, but that Jira ticket is one tiny slice of the overall spec because you're trying to build out a specification before you start development. And I think that's the core idea, is that you're not saying, all right, cool, we're going to build this feature, and then you just start building it. You're creating and intentionally creating, it's not like waterfall, but you're intentionally creating the spec up front. So I guess if we were to go back in time, back to like the early 2000s, when people were doing waterfall before, actually, when did Agile came out in the 2000s, I'm pretty sure, then that's probably closer to spec-driven development than what we do now, because they would have written out a really thorough, detailed spec document before development even started. I think the only reason that this is coming back now is because AI can do that so fast. You're not spending 3 months, 6 months developing a spec and working as a big team to come up with all the changes that need to happen across all the systems, because AI can just build a spec super fast.
Right, and Spec Kit sits in just that spec creation part.
Well,
right?
Spec Kit actually is like the whole end-to-end process, including development.
Oh,
so
wow, okay.
There's like, so Spec Kit in a nutshell is basically a set of skills. So we've talked about AI skills before, which to just reiterate to everyone who hasn't listened to the other episodes, a skill is just a prompt that you can inject by doing like a / command. And that's exactly how Spec Kit works, at least in Cursor and in Claude, the two harnesses that I've tried it out in. But Spec Kit is essentially a workflow, a sequence of skills that you run, starting with the Constitution. I'll come back and explain that in a second, because that's one of the most important parts.
The Constitution?
Yeah, the Constitution. So you build your Constitution. I'll come back to that in a sec. Then you create a specify. So you go /specify, and this is where you specify what it is that the feature that you want to build. Then you do /plan, and this will build out, it'll generate a series of functional requirements and user stories. And then you do /tasks, and it will convert the spec and the plan into a set of actual concrete tasks, like individual one-line coding changes it needs to make. This gateway has to change here. This function needs to exist here. This needs to be refactored. This test needs to be written, etc. Like concrete, single, small slices, tiny slices of functional change.
When you say the tiny slices, because I hear slice, it may be across front end, back end, middleware, etc.
So I guess it depends, because it's such a generic term to say slice, right? But so depending on which step you're talking in, when I say slice, like the spec itself that you're creating is an entire feature slice. And then the plan that you're making is user story slices. And then the tasks that you're writing are really concrete code changes.
So
write this test, write that test, write
it's trying
this
to get
implementation.
to the lowest possible. It's basically trying to turn everything into a one pointer. And it's like once you've done all the one pointers for this particular spec, that slice, it's like that user story is complete. This functionality is deliverable.
Yeah. So you're essentially, you're going from, we'll go past the Constitution, because the Constitution is like you write it up front once and then maybe you modify it from time to time. But really you spend the majority of your time going through the rest of the workflow, which is specify, plan, tasks, and then there's analyze and clarify. Clarify will ask you questions to kind of drill in on bits that are vague from the plan and the spec and the tasks that you've created. And analyze, it will clarify, you can run at any point. So if you do like /plan, you can do /clarify. If you do /tasks, you can do /clarify. And it will ask you maximum 3 questions. So it'll try to find the 3 most targeted ambiguities or vague things in your plan, spec, or tasks. And then you can answer those questions and it'll update them. Once you're done with your plan, spec, and tasks, that's when you run /analyze. And /analyze basically reviews all of the previous documents that it generated against the Constitution as well and aligns them all. And this is probably the most important thing about Spec Kit that makes it so good, because people don't realize it. We've talked about Perl, the workflow that I've explained to people before, where you do a planning phase, then an execution phase, then a review and a learning phase.
Yeah.
Spec Kit essentially does Perl. It's essentially doing Perl. It's planning everything. It's doing the execution, but it's putting review and learning like upfront. And I think the reason that analyze step is so important is because, and I don't think I definitely didn't think about this, but it's obvious now that I've experienced it. LLMs are iteratively working in a forward pattern. So they're not actually maintaining full conscious awareness of everything that's happening. As the context grows beyond like 100,000 tokens, especially over 200,000 tokens, there's this problem called the U-shaped performance curve. All models have this problem, even Opus, probably almost certainly even Fable. It's just because of the way that the math works in these models. And what that means is that as the context grows, the middle of the context becomes harder for the model to hold on to. So as you do your plan, spec, tasks, clarify, what's happening is you're getting drift. It's constantly drifting. I don't think you would ever get to the end of that workflow without running analyze and get perfect output. And I think that's where Spec Kit really shines, is not only does it produce human readable user stories and functional requirements up front that you as an engineer can read and go, this makes sense to me. This aligns with my understanding of what it is that I'm trying to build. But it can also self-analyze and self-heal where it started to drift and where that U-shaped performance curve started to introduce hallucinations and stuff like that.
Because otherwise you'd be doing that manually, right? I mean, you would essentially write your user story or something up front and get it to then follow that and then correct drift as it kind of goes. But you're saying Spec Kit kind of has that built in to try and
because of the skill, right? And at the end of the day, it is just a skill. It is just a prompt. So you could, and you can just go, because it's open source, you can go on GitHub, you can look up Spec Kit, you can pull out the skills and you could install the skills manually into your own harness if you wanted to and use them. But the thing that Spec Kit does on top of that is it actually has hooks and scripts that run as well as templates. So it has baked into it a template for what a plan document, a specified document, a task document should look like, what the structure of those documents should look like. And you can extend the framework with your own before specify hook, after specify hook, before plan hook, after plan hook, before tasks hook, after task hook. So you could essentially chain in your own deterministic scripts that add extra skills or do certain things, pull data in. I haven't really extended mine personally to do any of that stuff, but the capability is there and I can see value in why it would be there. So when I say that this framework is just a set of skills, it is in essence just a set of prompts that you run in a sequence, but it comes inside a framework that includes really nice templates and hook capabilities for you to extend the framework to do extra functionality that you personally want to like personal capabilities that you want to have, like potentially inject memory from a third-party system like Obsidian, which is a really common thing that AI engineers are doing now. They're using Obsidian to store markdown files and kind of enhance a model or enhance a harness with memory of your preferences. So you could run Spec Kit and then have it reach out into your Obsidian database and pull memories in consistently.
So how does it solve the kind of U-shaped problem though?
Yeah, so that's where the analyze part comes back in, right? So depending, when I first started using Spec Kit, what I was doing was I was essentially running this in one chat because I was kind of blind to the U-shaped problem. I was like, yeah, let's just plan, spec, clarify, task, let's do the whole thing all the way through. And then I ended up at like 700,000 tokens. And when I ran analyze, the analyze step took ages because it was essentially healing all of the damage that I'd introduced by letting the context grow so large that it had just started hallucinating. And so I actually got to the point where now what I do is I'll run plan and then I've got a skill called /handoff, creates a handoff document, and then I'll pass that document into a new chat, and then I'll run specify, and then specify, then plan, then tasks, and then clarify, and then analyze. And so analyze is essentially the part that I found the Spec Kit is really able to, I would say solve. It pretty much solves that U-shaped performance curve problem because you could manually move from one context to the next, but as long as you're running analyze, then it's kind of self-healing. It's going back and fixing those problems.
So how does it self-heal?
Because what it's doing is it's going back over. So let's say you've done plan, specify, and tasks, right? And each of those steps, I probably didn't really make this clear. Each of those steps is producing markdown files. So the markdown file itself contains all of your user stories, all of your tasks, all of your spec documents, and each step is producing that markdown file. If you were to run this in one long chat, then over time, it's going to lose awareness of the documents that came before. Because with that U-shaped performance curve, what that actually means is that the very start of a chat and the very end of a chat are the things that the model is the most aware of. So let's say that you start off with a prompt that's slash specify, and you specify out some really complex feature. Maybe it's some physics that you want to add to your video game or features for your website or something. That is going to be very, very strongly held onto in the context of the model, right? So it knows that the high level feature that you started with. But then over time, as you produce your plan documents, your tasks and everything, it's losing the awareness of the documents in the middle. So if you, for example, as part of your user stories, as part of your planning step, if your user stories included some functional requirements, some behaviors that the system has to adhere to, maybe there's business rules that have to be adhered to, something about the way that your hire accounts work or your user accounts work or something like that. By the time you get to the end of this workflow and you've started producing tasks, those tasks could be unaware of what the user stories actually had in them. It's pretty good. It gets most of it there, but it is going to miss some. It's going to get some gaps. And so when you run analyze, it's basically re-ingesting all of those documents, which again, if you think about the U-shaped performance curve, that means that the very end of your conversation now has all those documents. So you've basically brought them back into the window of awareness, the window of the smart zone where the model actually is still conscious of what it is that it's trying to think about.
So if I was to summarize my understanding of that, it would be that when you're running that analyze step, it's basically comparing the end result and saying, cool, this is what I've written up for the task. And then looking at the source of that and being like, what is missing from that?
Correct. Yeah. Essentially, it's going through your tasks, your spec doc and your plan doc, and it's comparing, were there any user stories that were missing from the spec? Were there any tasks that were missing from the spec? And essentially realigning them. So maybe it produced tasks that actually don't align to the original user story. Like, let's say when you do /plan, this is the point, and I probably wasn't clear enough about this, is in this workflow, you're not just /plan go. In each step, you're providing it all of your engineering wisdom and understanding of the system itself. So when you do /plan, you probably want to tell it what kind of database you want to use. You might tell it specifics about the system, like versions of things that you're using. And then by the time you get to your tasks and you've generated your tasks and you do /analyze, this is where it will go, well, hold on, in the tasks, I generated some tasks that use SQLite, but if I look back at your constitution or if I look back at your plan, you actually told me to use Dynamo or something like that instead. So this is where it goes through and it essentially does what you're saying. It compares all of the documents that were output from each of the steps before and aligns them. This is probably the best time to go back and talk about the Constitution. So
I was just about to bring it up. Yeah. I've been wanting to circle back. It's such a what right now. I feel like I'm going to be read my Miranda rights or something. What is the Constitution? Because it seems like this plays a big part of this model.
So essentially, Spec Kit's really good at greenfield projects. That's probably one of the biggest complaints that I've heard about it, and one of the biggest reasons to use something like OpenSpec if you've got an existing what they call brownfield project. If you're building out something for the first time, a brand new video game, brand new website, brand new application, I think Spec Kit is the way to go. It generally tends to be the consensus. The Constitution is the very first thing that you would do with your project. It's where you specify all of your dependencies, your versions, your coding standards. Like you would say
in different Markdown files, or where
in a single Markdown file. Okay. So the Constitution is a single Markdown file that contains all of essentially the guidelines for every subsequent feature that you want to build. The rest of the workflow we've talked about is something that you repeat on every feature. Every new change to the code base, you run that whole workflow. But the Constitution is something that you more or less do once, but you modify it over time as things change. But generally speaking, you only really run, you can run the Constitution skill. You amend the Constitution correctly. So you run /Constitution as the very first thing that you do in a project before you do anything else. And you tell it, let's say this is a TypeScript web application. We use Dynamo for persistence. We use Node, the specific version of Node. We use these specific versions of the AWS SDK. You can rely on your harness or your model to look up what versions of your dependencies you're using at any given time. But the thing about the Constitution is that it's built into the workflow. So there's no guarantee that your model is going to look up your package JSON or look up your dependencies file, whatever that is, and correctly look at the right documentation. So essentially the whole framework, all these skills that you can execute, part of what those skills do is it pulls in the constitution, right? So if you do /analyze at the end of the workflow, it's looking at your tasks, your spec, your plan, and your constitution and making sure that they all align. So for example, in my game dev project, I'm using Godot version 4 point whatever, right? So different versions of Node, different versions of Godot, they've got different capabilities that are available to them. You don't want your LLM to just go on the internet, look up the latest docs, and then start building out features that don't exist in your code base, right? And especially with like a game dev project, you can't just change your game engine willy-nilly like anytime you want. You start your project and you choose the engine version you want to use, and then most of the time, you don't update that engine version. That's the engine version that you're kind of stuck on, because if you make a drastic major version change in an engine, you're basically rewriting the entire application from the ground up. It's not like, the same is probably true in a lot of like web applications and stuff, but I think they're less.
If you change from say React to Angular, it's like you're changing the core engine, which you would have to rewrite the entire thing.
And it's not like changing from Godot to Unity or something. If you change from Godot 3 to Godot 4, it's like changing from Angular to React. It's a fundamental shift in how the engine works. So the constitution basically outlines all of the critical dependencies and the versions that you're on, so that if the LLM's looking up docs online to figure out how to solve a specific problem for you, it's getting the right version of those docs and it's doing the right thing and only building features that actually work with the engine that you're working with. You can also put things in there like we follow solid, we follow clean architecture, but the trap is you need to be really specific. The constitution needs to be really, really explicit, because whatever you put in there is going to underpin every single feature that you build. So one example of where I was too vague with mine was I said we follow solid, and I gave it like a one-line sentence for what each of those things mean. And for open closed, it was open to extension, closed to change. And the model translated that to, okay, I can never touch existing code. And it built abstractions on top of abstractions on top of abstractions because it refused to touch existing code, which like in some ways makes sense, but not when you're changing the fundamental business rules that code originally wrote.
So if you screw up your constitution, you're just stuffed.
If you make mistakes in the constitution, it's going to bleed into the entire workflow. So it's the most critical thing that you get right.
But you can correct it because you're pulling it in each task, right? It's not like each.
So here's the thing. It's very resistant to making changes to the constitution. If you tell it, we need to change the constitution, then it will. But it tends to treat the constitution as gospel. It's like, this is the law of the land. If I'm thinking through a problem, I have to adhere to the constitution. It's really strict about the constitution and what it does.
And you mentioned the constitution includes all the things. So coding standards, linting rules kind of style. Like, it's how restrictive or how big is this constitution? Because if you said we're doing we're making a single page game with persistent state in TypeScript React 17.6, for argument's sake, like, do I have to specify like the style? It's like you use hooks and componentization, or you use Zustand, you never use context APIs. Like what I'm just trying to mentally build up a model of what the constitution looks like.
Yeah, it's a description of the project and the behaviors that you want the code base to adhere to. You mentioned linting rules. You don't have to put your linting rules in there, for example, and this is where the pre and post hooks come in. So you can hook up your linting to a post. So the only skill I haven't mentioned is /implement. So after you've done plan, spec, clarify, analyze, task, all that stuff, that's when you run /implement. And that's pretty much that skill. You don't tell it anything. You just go /implement, and it's pulling in all the docs and it's building everything. You can have, as part of /implement, run lint at the end of the skill, essentially. So, I mean, you can also build it into your constitution that all code changes must be linted. But for example, in my constitution, I said we do TDD. So every subsequent spec that I produced, all of the tasks that it built as part of the /task step came as test logic, test logic, test logic, test logic. So it's not like the constitution's not huge, but
can it start small and kind of grow as your project grows?
Yeah,
as well?
And you should, right? Yeah. It's essentially the same as the Constitution of the United States, right? Yeah. You make amendments to it and you build it up over time, and you continually extend it to include new rules that you want future tasks. So if the LLM harness model, whatever word you want to use, If the model does something weird and you want it to stop doing that, you would update the constitution, which is what I essentially did. Was I found that open closed thing was not doing what I said, so I amended the constitution to say open closed is open to extension, closed to change. Where critical business logic changes from its its original purpose, they're essentially created exceptions to the rule, right?
The restriction on some of that stuff is obviously going to be dependent on the language and the frameworks that you're actually implementing in, right? Like in some frameworks, it's more obvious what open and closed means. Like, oh, I've got this interface and this abstract class and I can extend the class, but I can't change the internals of, the protected methods and stuff.
Yeah, so in your constitution, you would prefer to, this is like a really good point. In your constitution, if you were to say solid, open, closed, and what a really concrete understanding of what that looks like in the language you've chosen, like you've chosen C or C++ or C# or something like that, like you said, with interfaces, you can extend interfaces. You could tell it explicitly, open means this, closed means this, open to extension. In this language, we do that by extending the interface, never touch the original interface unless explicitly told to. So obviously there's always going to be an exception to the rule, but that's essentially what I would do is I would go in and I wouldn't just say, we do solid, single responsibility, open to extension, closed to change. I would explicitly say single responsibility looks like this and maybe give it a code example. Open closed looks like this, give it a code example. Where you can be explicit and concrete, you should always be explicit and concrete. It is high level in the sense like for my game dev project, I'm building a 2.5D, if people don't know that, like the Octopath Traveler. It's like pixel art in a 3-dimensional world. So it looks on the surface like it's 2D art, but it's projected onto a 3D space. In my constitution, I explicitly call out this is a 2.5D game. So whenever it's thinking about building tasks, it knows, okay, we're not building a 2D game. Everything I do has to use the 3D components of the engine, because in Godot, for example, there's 3D components and 2D components, and there's usually a 2D variant and a 3D variant of all the different components you can use. So it knows I can't use the 2D ones because they render on a canvas that's flat against the camera. That's not going to work in our game.
And it suddenly pulled in 2D variants, that would just break your whole thing.
It wouldn't work. Yeah, it's not going to render the way that we intend it to do. So there are some things that are generic in the sense like, what is the project you're building? I'm making a 2.5D game. I'm not explicitly explaining 2.5D means this. It's smart enough to know inside its own model, because if you put 2.5D into the model, then to get like technical about how models work, the distance between the two vectors for 2.5D and 2D would be very far apart, right? Because that's a 3D game. So they wouldn't be as close together as 3D and 2.5D. So it's like, oh, I'm working on a 3D game purely because of how the statistics works inside the model.
So what you might do then is you might bake in, we have linting rules and we have a formatter file that must be respected when implementing. That might be part of your constitution, but you're not going to go through and change those because you want those files to be external, easy to change, easy for devs to understand. So your coding style and standards might be in there, but it's not, oh, we use braces on the same line, we don't use casting, we don't use currying, or does it say those things explicitly?
You would, yeah. So if you're like, I do not want any currying in my code base, you would call that out in the constitution. I would say I would give it code examples in the constitution to say, this is what our tests look like. When we mock, this is how we mock. And this is why, like, over time, as you build a project with Spec Kit, you'll learn the things that it makes mistakes on, and then you go back and you do an amendment to the constitution and you update it with a section that says, and I would encourage people to have a conversation with the model. So you, for example, you run tasks, you output some code, you look through the code and you go, oh man, it's mocking things in a really weird way. Or maybe you're an anti-mocker, like you believe that you should only mock boundaries and never mock internal modules, right? Which is like, a lot of people go, no, mock everything internally and your unit test should be completely mocked. Other people have a mocking as a code smell mentality. So in the constitution, you would say, you'd have a conversation with the agent. I notice that you're mocking my internal modules. I want a rule in our constitution that explicitly calls out what mocking looks like at the boundary and what mocking looks like for internal modules. I would like code samples in my constitution. It'll generate something and then it'll say, do you approve? You're yes, and then you can update the constitution like that. Concrete examples are always better, I find. You always get better results from LLMs when you explicitly tell it give it an example what the code looks like.
We talked a lot about the Constitution, and I feel like there's a lot more you could probably get into it. But I kind of had two things I wanted to go through, kind of stepping away more of a high level. One of them is like walking through the process of setting up a brand new project, a greenfield project with this because we've talked about the Constitution and you've mentioned all the commands you kind of need to run for the workflow. But I think it's still a little unclear exactly like how you would actually run this in a project. The second one was using in an existing project. You said brownfield, which sounds like a slur to me, but
yeah, it doesn't sound great.
But how would you run that in something that kind of already exists and setting up a Constitution for the whole project? I don't really know how that kind of would fit in.
So it's similar to installing any other dependency. Whatever your package manager is that you use in your application, you would essentially install Spec Kit to your machine or whatever. So
to the machine or the project itself?
Either, right? So like, in your projects at SEEK, for example, you could install a tool like Scuba locally, or you could install it into the project, depending on how you want to do that. You put it somewhere where you can invoke the CLI tool and you do Spec Kit init. I'm pretty sure it's Spec Kit init, and that will essentially install all of the skills. It creates I think it's called .specify. And basically inside that dot folder, like a .github folder, a .buildkite folder or whatever, that's where it has memory, it has a memory directory where the Constitution lives. It has a plan directory or a spec directory. I can't remember the name of the exact directories, but it essentially is like installing any other dependency into your application, right? It creates a folder once you do the init, like git init, right? Very similar, which makes sense because it's made by GitHub, right?
Yeah.
So yeah, you basically install the CLI tool on your machine through like brew or UV or whatever it is that you're using to install dependencies in Bash on your machine or whatever shell you're using. And then you run Spec Kit init. That'll install the .specify folder, which includes all of the skills. And then you basically, at that point, you can just run the skills. Because skills, like in any harness like Claude or Cursor or whatever, there's like multiple different places that skills can live. And one of them is at the project level. So it installs the skills into your project and then you're good to go. And
you don't need to add them anyway. It just picks it up automatically?
Yeah. Well, cool. At least Claude and Cursor do. Yeah. As soon as you create a skill.md, as soon as you type / into the chat interface, it immediately is essentially scanning a live copy of anything that's in those skill directories.
Yeah, cool.
Question. When it comes to, you said you could do it at the project level or globally. Now, I've shot myself in the foot with this before where I've had the same skill and two different variants of that, one at the project level and then one at the global level.
Yeah.
So if you're saying you're like, yeah, you can install it globally and then just init it in a project folder, how do you prevent yourself from...
You can install Spec Kit CLI anywhere. I don't think you can install Spec Kit, I don't think you can Spec Kit init into your machine, right? You could technically copy paste the skills, but I don't think the CLI tool, maybe it can, but that would be crazy. My understanding is that it can't. But
okay, so when it's running, it's going to be looking for a local project reference as opposed to going globally. Because Cursor, for example, you said a skill could be anywhere. It could be anywhere in your current project. It could also be in your user profile, and that's kind of a
I don't think that Spec Kit would install to your user profile, and the reason for that is because it has those hooks and the templates and everything. So if you were to, let's say you were to install Spec Kit into a project and then manually copy paste the skills files out of there and into your root directory, like into your user agents directory or user cursor directory or whatever, I don't think that would work because in the actual prompts themselves, it has references to the neighboring documents. It has references to the template. It has references to these hooks files and scripts and stuff like that run. So I don't think that would actually work. And I would hope that it kind of pushes against you because it's kind of very project specific. Like the prompts themselves are generic, but over time you're going to build up like scripts and stuff and hooks, pre and post hooks and stuff like that. When I said global, I'm talking about the Spec Kit CLI. You can install the CLI Spec Kit tool globally or locally, and then you do Spec Kit init, and it'll install into whatever directory you're in at the time.
I was just going to keep going on the making a website or game. So say you're making a new game, you've run Spec Kit init, whatever it is. Where do you go from there?
You start with Constitution. That's
you
the very
start
first
writing
thing
stuff down?
Yeah. So you install the CLI tool, you run Spec Kit init, and then you do /Constitution. /specify -Constitution. I can't remember exactly the actual skill names. It'll be really obvious as soon as someone's right. If you do /Constitution, it'll figure out which of your skills aligns with that naming convention.
Right.
But you run /Constitution, you tell it a high level understanding of what the project is. Like, so for my game dev project, we're doing a 2.5D farming sim. I want this kind of camera angle. This is the version of Godot that I'm using. I want to deploy to PC only, so I'm not making it on the Nintendo Switch. I'm not making it on the PlayStation, the Xbox, or anything like that. Some bits can be high level, like I'm making a game in Godot. It's a 2.5D game. I don't have to specify what 2.5D is, whatever. Give it an understanding of what the project is, and then give it concrete coding standards. That's the two things that I mainly use the Constitution for: is high-level understanding of the project, mid-level understanding of the dependencies that make that project, like versions of the Godot engine and whatnot, and then as concrete as possible coding standards.
Mm-hmm. And are you putting you're not putting features in there as well, right? You're not putting this game will allow me to jump on platforms and stuff. Is that?
That's where you would be building features. Yeah.
So
I mean, if you, in your Constitution, if you say we are building a platformer in the vein of Hollow Knight.
Yeah.
Whenever you write a feature, it's going to go, oh, our Constitution mentions Hollow Knight, and it's going to go and look up Hollow Knight on the internet. So it's going to try and make the jumping work like the jumping in Hollow Knight. It's going to try to make the combat work like the combat in Hollow Knight. But at the end of the day, you're specifying feature by feature. So if you tell it, here's the thing that I find really cool about the Constitution is, if you want a vibe code, the Constitution is the gospel. You really need to make sure the Constitution has as much clarity as possible. But if you don't vibe code and you're really explicitly saying, I want to build our first combat feature for our 2D platforming game. I want the hitbox to be 1.5 times the height of our player and 1 times the width of the width of the player. Then it's going to take whatever the current height and width of the player is, and it's going to make you a hitbox that is that size. But if you say, I want a hit animation, I want a basic hitbox, then it's going to go, well, I'm going to make something up. And in the Constitution, it said Hollow Knight. So it's going to look up any research information it can about Hollow Knight's combat system. And, Hollow Knight used 2.5 times height and 1.8 times width. And it's going to basically mimic that as much as possible. So if you're a big vibe coder, Constitution becomes even more important than ever. But at the end of the day, every feature that you specify, that's the /plan skill is where your engineering really comes in, and it becomes really important for you to say, this is exactly what I need to do. So you /specify, I want to build a basic jumping mechanic for my platforming game. I want it to have a really nice physics, or I don't want to use physics. I want the math to be calculated manually. I don't want to rely on the physics engine.
Is this what you would run straight after, right? So after you've written the Constitution, I'm now looking to write my first feature. Is the first thing you're doing is /plan and then
specify?
Oh, you specify.
Yeah, so /specify, you're specifying the feature. You give it maybe a paragraph, right? I'm building a jumping mechanic. I want it to feel like Mario. I want it to be very... I want the player to have fine control over the jump. I don't want to rely on physics. Like you're giving it that loose interpretation of what the spec is, of what the feature is that you're building.
Right.
Then you do /plan, and this is where the engineer comes in, and this is where you start to really spec out. These are the math equations that I want to use. Right?
It is /plan. Are you giving it more?
Plan is where you add the detail, yeah. So specify is where it's going to produce your...
Yeah, what's the output of the specify? Is it a markdown or something? Where it's
pause for 1 sec.
Yeah.
Spec Kit /specify. I got to try and remember exactly what each of these steps do. One of them produces functional requirements. One of them produces user stories, and the other one produces tasks.
I see.
So we've heard a lot about the high-level Constitution. If you were to break out the skills that we run kind of one after the other.
That's what I'm trying to go through. I was wondering kind of what those were actually working through a project, I suppose. Because I find that super interesting, what is kind of the workflow with something like this. But I think Seamus is just looking that up real quick.
Yeah, I have a project that I'm running, and I'll pull up my spec.
Let's do it. We're doing it live.
Cool. All right, sweet. So when you start running your commands, your plan, spec, tasks and stuff, that's when it produces a specs directory, so not part of the .specify folder. The .specify folder is like where your hooks live, it's where your commands live, it's where the skills actually live and all that kind of stuff.
Are these all committed to the repo as well?
Yeah, they're committed to the repo. When you start running the plan, specify, tasks and stuff, that's when it produces a specs directory. Now, in terms of the actual individual tasks, if you run /plan, that's where it is producing. The plan is when it starts to do things like research what the technologies are that it needs to use, and it's building the concrete technology plan, the framework that all the tasks and everything need to build on top of to actually make that feature work.
Will it ask you questions about that too if it's unsure?
Yeah. So you're trying to have a conversation with it. I have a grill me skill that I use, like /grill me, and I'll have a conversation. I'll be like, I want to make a plan for this feature. Grill me on this plan, and I'll give it. I want to use I don't want to use the physics engine. I want to calculate the math ourselves. Then it'll say, what math do you want to use? Here's an equation from Mario. Here's an equation from Sonic. Here's equations used for other popular games. Which one would you like? And you have a conversation with it until you produce a plan. And that's part of the research file, right? So it creates a plan file and it creates a research file. And these things both work together. And once you've done that work, that's where you do spec. And spec has all of your user stories. When the user presses space, jump is initiated. When the user releases space in midair, the arc is cancelled and the player begins to fall. So like that's where your actual user stories come in, the concrete, well, not quite concrete, but the acceptance criteria, right? The same thing that we would put in a Jira ticket. And then once you do tasks, that's where it actually pulls your functional requirements together, pulls your functional requirements from the previous steps and starts to generate concrete tasks for what code needs to change. We need to test in this exact file. It needs to test this exact math. So it's actually like, this is where you would produce Jira tickets from the task step.
So I'm going to jump ahead a little bit. We've done the spec, done the constitution, everything's there. It's all, atomic design or at the unit level, whatever. We got the Jira tickets. So you mentioned there's a /implement bit. So does
that happen straight after? Now that you've got your task, you just implement?
Yep.
Great.
I haven't needed to say anything other than run the task, like run the /implement skill.
Yeah, because it's probably got so much info already on what needs to be done.
Yeah, and that's the whole thing about Spec Kit, right? Is I literally spent 5 hours having a conversation with my model on one feature I wanted to build. And once I was at the end of that and all of the functional requirements, the user stories, the research was done, we knew exactly what math we were using, the physics we were using, everything else, then I just go /implement and I just let it run and I just walk away. And this is why, like, on my machine, it's got complete access. I let it do whatever it wants. If it blows up my machine, I don't care. Just let it blow up my machine. Because I used to come back every 5 minutes and be like, approve this command, approve that command. It gets really exhausting. And eventually I was like, if I'm spending 5 or 6 hours having a really detailed planning conversation with Opus or Fable or whatever, I don't want to have to keep coming back and monitor and just go approve on all these little micro commands that it's doing.
Well, after implement, I think there are some other steps as well, right? Because you did mention the analyzing or whatever, the course correction or something like that as well.
Yeah. So
does that happen after implement?
Implement's the last thing that you run.
Oh, right. Okay.
Yeah. So you start a project, you spec kit in it to install the skills and the framework into the project. You do /constitution to build your constitution, where you give it all of your coding standards and your high level understanding of the project and whatever concrete examples you can of your coding standards. Then you start to build your first feature. You go through that /plan /specify the feature you want to build,
tasks,
/plan to plan out the actual concrete understanding of what it is that you want to do, /tasks to generate the actual concrete implementation detail, like this file name, this math equation, that's where the actual tasks are being generated. Then you do /clarify or /analyze, always /analyze. Clarify is optional. I would say you don't often need to do it depending on the model that you're using. But /analyze is the thing you have to run after you do those 3 steps, because that's going to realign all of the documents that are created before and make sure that any gaps are analyzed and cleaned up. Then at that point, you've generated your research, your plan, you've generated your spec, you've generated your tasks, everything's aligned to the constitution, and you just run /implement. So /implement is the last part that you do for a feature.
After it's implemented though, if it comes back and it's not right, where do you loop back to? You're like, this looks all right, but we need to tweak it because it's not exactly what we'll do. You go back to the analyze or the plan, or how do you modify kind of what's been output and generated?
Yeah, that's a really good question. I find myself jumping between different modes when I do this.
Yep.
Sometimes my instinct is to, how can I rerun these skills to make it change stuff again? But after spending 5 hours or 2 hours or 1 hour, however long for the feature that you're building.
You just ship it.
So I don't want to go back into, because it is kind of a slow process to go through. I don't want to go back and do that whole process again. So I'll just usually make incremental tiny changes, and they're just not part of the spec.
Yeah.
I'm just saying, like, this thing was a bug, we need to fix that up a little bit. This thing was a bug, we need to fix that up a little bit.
Right, that's where you kind of break out of using this tool and just use regular.
Normal LLM, normal cursor Claude stuff.
Yeah, cool.
Okay, cool. So at that point, so it really is the bootstrapping of the software development lifecycle. It's not no, you keep using this forever. It's like, no, you do your greenfield, you build your thing, and now that the thing's built, you have to do all the other stuff. So you have to go and find the fact that, we forgot to implement canceling the arc when we jump.
Yeah, like I don't think that I would, I mean, some people might debate this or disagree with this, but I wouldn't use Spec Kit to do like bug fixes and stuff. That's just massively overkill. And I think that's something we haven't talked about is there is a lot of token burn doing this because you're having a really lengthy planning conversation with it. And for people that don't know, output tokens are like 4 times more expensive than input tokens, depending on the model that you're using. And so because Spec Kit is outputting a significant amount of documents, that's a lot of output, right? And that's before it even writes a line of code.
What's the cost that you found it incurs when you're playing with these?
Well, at home, I'm only using the Claude subscription, so I'm not paying like per token API costs. But here's the thing: if I was paying if I was paying SEEK's model, or I was paying like an employer's model doing the per token API costs, probably I might be much stricter about my use of Spec Kit and exactly how and when I use it. But I was using it with Fable and not reaching my subscription. I'm on like the max subscription, like the $180 a month or something like that, which is significant. A lot of people don't have that subscription. So if you're on a small subscription, you probably would find this challenging. And this is where I'm starting to hear more people saying, hey, maybe instead of Spec Kit, you should use OpenSpec because OpenSpec only produces 3 documents.
Oh, okay.
So it's a lot less output.
Does it like cut down the sort of commands you run as well? Yeah,
it's faster. You spend less time having conversations with it, and it apparently produces really good results. But I haven't had much experience with it yet.
What I find really interesting, hearing all of this in my mind, I'm tying it back to what is the use case for me at Seek to use this. So if I just know there's core new business requirements or business use cases, it's like I can't really use Spec Kit for that because there's a whole historical context of the systems and architectures and all the other stuff at Seek that's missing, and it's kind of like it's not really useful.
Yeah, you'd have to write that whole constitution.
Yeah, and when you've already got a very mature piece of software, Spec Kit's probably not a good idea to use. Is that what I'm?
Or maybe unless you're kind of going full into it. I mean, if only a single dev is picking it up, I feel like there's a lot of commitment to go in. That's kind of what I'm feeling.
Yeah, I don't think it's something that I would suggest you don't have a single engineer using Spec Kit in your team on your project, unless that engineer is the only person working on the project. Like you're doing a spike for a new thing and you know that you're going to build this. Like you're spiking out, you're doing a proof of concept, but you know this is on the roadmap. You know that we're going to build it. If you want that engineer to build something quickly, if you want that engineer to build a proof of concept and not have to rewrite it and rebuild it, they're going to spend maybe a month or 2 months doing a really long POC on something, and you're very confident that you're going to do it, which is kind of, I guess, is like an oxymoron. You're doing a proof of concept, but you're really confident that you're going to do it.
So you're building for a pilot, basically. You're like, we're essentially going to do an MVP soft launch of this, and if it takes off, then we're going to scale it. So we want to build it once.
That's probably a good institute.
But it's still proof of concept in the sense that it's like it's got a certain amount of MVP, but it's written for scalability on day one.
Yeah, so I would say like good use cases for a company like Seek, for a big organization, would be brand new systems that no one has started building yet, and you've already gone through POC or spiked it or whatever. Like you know you're going to build this thing. Piloting some new applications, so similar kind of concept, or where your whole team is all in and you're committed to building out your constitution and getting that right up front, because if you don't get that constitution right, the AI is going to start doing weird things and start building logic that's really not great. I have struggled to introduce Spec Kit into an existing system because of the challenge of building out the constitution up front and having all the context that it needs or all the standards that you need. I think if you're in a high-functioning team that already has really good documentation around your standards, you're probably in a better place than most teams to start this off. But I would heavily be considering OpenSpec because, like I said, the cost of running Spec Kit is not trivial when you compare it to something like OpenSpec. I think in general, though, what it taught me is that spec-driven development is the way that I would go whenever working on a project, fresh or with a new team. If I was to do a startup with another company, like if me and a bunch of people were to get together and do a startup, I would 100% be using OpenSpec or something like that. And I also think that I do see it as being the way forward for engineers and product managers to collaborate more closely, because the quality of the user stories and the quality of the functional requirements and the detail of the tasks that it outputs is the level of detail that I've been aiming to achieve in all the teams that I've been working in for the last 5 or 6 years. Because every team I've worked in where we have really explicit, concrete requirements around what the user's expectations and acceptance criteria are, what the actual code changes are that need to be, I could do Spec Kit up until the task step and then hand it over to a grad. And I mean, yeah, at that point you can just do /implement. But if we didn't have /implement, I would do it up to that step and then build out your Jira tickets from there. And I could see a world where we don't run /implement ourselves manually as an engineer sitting in front of the machine, but we push the tickets, the /task step, the output of that, we push that into Jira tickets, and there's some agent listening, subscribe to the pipeline, and it just sees a ticket, picks it up, runs /implement, and some other agent reviews the code. Like, I could definitely see in 12 months' time, this is a world that a lot of teams and a lot of companies are going to be living in.
We should wrap this up, but I just had one final thing. We've already talked about some of it, but just the friction. You said there is friction in this, and we've already talked about some of it in general, but I guess just a quick fire. What are some of the main, we've already touched on where it can kind of slow us down, but are there any kind of more where there is friction in using this tool?
Yeah. If you're going to get the most value out of this, then you want to use a high reasoning model. But the downside of using a high reasoning model is they take a lot longer to reply. So you're naturally taking, like you're creating much more process. There's a lot more thinking that you have to do up front. You're not just jumping on the computer and going, I'm going to make a game, and you dive into the code and you start building something. You're spending a significant amount. It's the same thing that we deal with at work, right? We have months and months of planning conversations and design conversations where there's product managers and designers and analysts and all these people involved before we ever start writing code. Like there's a joke that's going around a lot because we're not seeing like the 10x, productivity from code, from AI, from agents, because engineering was never the thing slowing us down. It's all the planning that we're doing.
I have been saying this for years. Engineers were never the bottleneck. And I'm not throwing shade at the people who make the decisions and have to figure out what to build.
It's just process.
I'm just saying, like, when it comes to us, it's like, it doesn't take us that long to build stuff.
Be a 10x processor.
Yeah. So the main friction, I guess, is like I said, if you want to get the most value out of it, you probably want to use a high reasoning model. High reasoning models are slow to respond. You could turn off reasoning and use a frontier model with reasoning turned off. You get faster responses, but you need to be way more critical of the output that it's producing. You need to really rely on that analyze skill and really pay attention and give it more detail up front.
When you turn reasoning off, does it just go by gut feel? Is that
essentially the loop? When reasoning's turned high, when you've jacked up the reasoning, the loop is going to force the model to talk to itself. That's what those little thinking bubbles are that come up in Cursor. It's essentially taking its own response, feeding it back in, taking its own response, feeding it back in, going.
And each of those count as output tokens,
Yeah.
So the output it's producing for itself to then ingest again, kind of expensive. So even if your total output, you're like, I only output 100,000 tokens. Nice, that's cheap. It's like, no. It output like 2 million tokens.
This is why in like the Cursor dashboard, you'll see like a request that only had 200K tokens in your Cursor window actually racked up like 1 million tokens because it was like having an internal conversation with itself. And the other point of friction, which I've kind of mentioned but not really been explicit about, is it is really, really exhausting to sit there and have a half-day long conversation or a 1 hour conversation, however long you want to spend with it. It's really exhausting because you're not sitting there and working through a problem with your hands on the keyboard and building the thing out and seeing the features change in front of your eyes. You're not building components in the UI, watching the render change and then thinking about it a little bit, building a little bit. You're just thinking.
Yeah.
You're just thinking about high-level and low-level concepts, in your head. And that, like everybody remembers when you're at uni, like try sitting in a meeting for 5 hours a day. It's pretty brutal. I can definitely see it being the future of how we do the process part.
I need a live demo now. That's what I need. I need to be able to see it.
Well, GitHub have released a series of videos that you can watch that literally explain most of what I just said with visuals and a little bit more detail.
That's fantastic. Yeah.
I love it.
If you need to learn more, check that out. Thank you so much, Seamus. I feel like you were the special guest in this one.
You were the special guest.
The last special guest for the season.
Yeah. This is the final episode. We'll see everyone in the next season.
Thanks for listening.
As we sign off for Season 3 of SEEK Bytes, we'd like to thank all our special guests who joined us this season. Elder Markison, Kat Vassallo, Andy Maxey, Trevor Kilvington, Helen Giapizakis, Trey Narath, Tetko, Eddie Newan, Asha Yokalari, and Leon Belabrov. And also a big thank you to Arnav Jain, who joined us on the hosting crew this season.
A big thanks to the media, marketing and ops team here at SEEK, especially Alison Downs, Dylan Tucker, Pip Duncan, Jessica Cox, Angela Martins and Andy Maxey for providing the facilities and supporting the recording and publishing of our episodes here in the Melbourne SEEK office. We also need to thank Lisa Tobin and James Ross for believing in and giving the freedom for the crew to create a podcast based around SEEK's technology people. And a special thank you to our ever-present producer and editor, Glenn Wilson.
Finally, a huge thank you to our listeners, those who have stuck with us from the start and new listeners alike. This is a niche podcast, and we're especially grateful to have a growing audience across the globe that keeps us motivated to create more content that we hope adds value to our listeners. While it's the end of Season 3, we will be doing some ad hoc episodes between now and Season 4, so do stay subscribed as we'll be dropping them without warning. On behalf of us, the hosts, Seamus, Elliot, Will, and Arnav, thank you for listening to Season 3 of SEEK Bytes, and we will be back for more in Season 4, coming soon.
See you next time.